In my last video, I started using a PSOC to do some prototyping for a video card that I'm hoping to eventually build here. Looking for a 640 by 480 output that I can use in my 286 build. And in the upper left is the output that I was getting from that circuit at the time of that video. And the lower left is just what that breadboard looked like. So really the only thing of notable interest there is there's a PSOC and then there is some flash memory. And I'm using the flash memory to store the data for this image of the bird. And I'm using the PSOC to just experiment with different outputs of signals for the VGA timing and making sure I can generate the proper addresses to pull from memory to reproduce the proper image on the output. And that's just using flash memory at the moment, which obviously is not usable in a real system. I need to turn that into something that's not read-only, but something that I can be dynamically changing, in other words, RAM of some sort. In my last video card, I was using dual port memory, which was great because then both the 286 and the VGA output could access that memory pretty much simultaneously. But I'm trying to now do this without dual port memory, and that presents many challenges for me to figure out how to do that. Primary reason is as I go from my last card with a resolution of 320 by 240 to a card that's 640 by 480 or even 800 by 600, I need a lot more memory. And the dual port memory I was using before was somewhat affordable. It was expensive, but it was somewhat affordable. But trying to do that with a 640 by 480, the larger storage capacities of those dual port static RAMs are really expensive and beyond what I'm able to spend on this project. So I am trying to figure out how to do this without dual port memory. And then what you're seeing on the right of the screen is just a document I shared on my blog, just trying to think through what are some of the pieces that I'm going to have to take into account as I build this out. And I've been putting some thought into that, and I posted this to Reddit, and I've had some nice discussion going on there. And thank you especially to Liquid Nyquist, if that's how you pronounce your name, as far as just input on an architecture that might be doable here. And that's kind of what I'm proceeding with, is trying to take this first set of notes here. That's just some miscellaneous thoughts and kind of a blocky, not overly organized diagram, and turn that into something maybe more of a schematic and something that I can eventually test out on the breadboard. And that's what I'm going to do in this video, is I just kind of walk through maybe a couple of quick updates of where I'm at as far as what I'm chasing for the design. And then I'll pull up the schematic as I have it built out so far and talk through that. And as always, looking for feedback. This is a lot of new territory for me, so I'm learning as I go through this. And if you're catching something and you think there's a better way to do this, definitely let me know. And maybe what I'll get into first is just a recap of what I'm using for my address space on my 286 system. So this is the address space. I'm using real mode on my 286, which means I have 1 megabyte of addresses that I can use. I'm using the first 640K for RAM, the upper 256K for ROM, and I've set aside 128K for video. And in older videos, I did show running my 320 by 240 video card using that 128K space, basically. As I try to get into higher resolution, though, that is not going to cut it. I need more than 128K. For me to do 640 by 480 with 1 byte of data per pixel for color data, I'm going to need at least 300K, or I will need 300K, 300 kilobytes of space that I need to be able to work with. So my plan is to do this. I am going to use 2 frame buffers. Each of them are going to be half a megabyte in size, which, if you think about it, that's maybe a challenge that I'm going to have to figure out how do I do that. And let me first say that the reason I'm going with the 512 is so that I can support up to 800 by 600. And I want 2 separate frames, so I can have maybe an active frame that's being output and another frame I can be building content in, and then once it's ready, I can then flip that to my output frame. That type of approach is what I'm trying to do here. If I look at my 286 address space, though, I'm only looking at 128K, so how am I going to get to that full 1 meg worth of frame buffer data? Well, my plan actually is to shrink that 128 down to 64. And so I'm going to work with all of my video memory in 64K chunks, which probably isn't a big deal because on the 286, I don't have a single flat linear address mode that's available. I have to do everything in 64K segments anyways. So I'm going to use a 64K segment here that will be exposed as my video card. And then I'm setting up an I/O address on my video card. So this is separate from the memory mapped space on the left. This is an I/O address space on the 286 processor. And I'm going to set up 0A as the address within that 64K address space that the 286 has to offer. And I'm going to put in a register there, so a 16-bit register. And within that register, I'll have 3 bits of the 16 bits that'll tell me which is the active segment for my manipulation from the 286. So if I want to write to memory or I want to read from memory, I can specify first which segment I want to work with within the 512 or the 1 meg space. And actually it'll just be within a 512K, a half meg space. So I can say within that half meg for that specific frame, which of the 8 64K segments do I want to have be active. So then I can set that with an I/O write. Then I can do my manipulation with direct memory mapping. And then I can flip to a different segment, do some more manipulation, etc. So that's going to let me cut down my video window to the 64K and still give me access to the full 512K for that active frame. And then there's another bit in my register that's going to let me change which frame is active, frame 0 or frame 1. So I can choose a frame and then I can choose a segment within the frame to be working with. And then I can also choose on the output which frame 0 or frame 1 is actively being output. So that's the theory behind what I'm trying to do. So let me flip over to my schematic tool and start walking through this a little bit. And so here is Easy EDA, that's the tool I've been using. Before I zoom into this, in the upper right, here's the PSOC I was using last time. I have an oscillator that feeds it the appropriate pixel clock. I was doing all the counting logic inside of that, and then the sync logic. And that was generating my addresses that I would then use to pull from that flash memory, along with generating the H-sync and V-sync that go out to my VGA connector. And then the data that I'm basically pulling and latching here from my flash memory. So that was what I went through previously, but now I've added or built out a bunch of the rest of this. And if I go over to that PDF file that I had for a second, this is what I shared last time. And again, this is just kind of some blocks that saying, okay, I've got some memory and I need some multiplexers and I probably need some transceivers. VGA output I had already covered, and I know there's this additional PSOC I'm going to use to do a bunch of really prototyping, and then this register that I was just talking about. So this is what I had in mind. Now I'm starting to turn that into a schematic and the rest of this. So maybe let me just run through some of these pieces. I've got my ISA slot, the actual edge slot connector up here that I'm going to bring in my data and addresses for my 286 system, along with signals of whether or not I'm reading or writing, and is it for I/O or is it for memory, because I'm going to be doing both with this card. This card will support both memory reads and writes to do the actual video memory, and then those I/O is to read and write that register. I have other things like a clock, a reset. BHE is used to help me identify, along with A0, whether I'm using a lower byte or an upper byte when I go to an address, because the 286 essentially wants to read, when I go to read an address, typically wants to read a word at a time, so 2 bytes, and it'll actually use, I can use this BHE and A0 to understand, am I looking for the lower byte or the upper byte. And as I look at my design down here, I'll come back to the register in a second. I'm going to flip to the middle where I have the actual memory. And so I have a pair of static RAM chips for frame 0 and a pair for frame 1. And you'll see that I'm going to have to decide when do I turn on each of these chips, and that logic is all going to happen in the PSOC that I have off to the left. And so that PSOC is going to have to know about A0, it's going to have to know about BHE, it's going to have to know about other addresses, address data, so that it knows which of these I'm working with. Along with, should it be the 286 that has control of the memory, or should it be the video, the VGA output that has control of the memory? So here's my memory. It's wrapped with some of these multiplexers and also transceivers down here. But to the left of that, I have this PSOC that's going to help me hopefully do the logic to control all of that access. And then this portion here is this register. So it's a 16-bit. It's a single 16-bit register that I will be able to read and write bits to and from. First of all, let's talk about the register. I have a pair of 74 245s, and so these are just bus transceivers so that I can do a couple of things. Well, first of all, if you look at these 74 173s, these are flip-flops, so I'm going to use those for my registers. 4 of these 4-bit flip-flops give me my 16 bits, so that from my 286 I can reference an IO address and I can access a full word of data or 2 bytes of data. And this is going to pull directly from the ISA data bus, and it's going to do that when I tell it to read in using this signal, this register in for the high or the register in for the low. And if I go to read the high, it grabs the appropriate top 16 or top 8 bits to pull into those flip-flops. And then down below, I have the same thing for the low. Now, the reason I moved this over to I/O instead of address space is I didn't want to start taking up address spaces outside of the 64K that I'm going to use for this segment window. It just felt unnecessary to take more of an address space for a very, very small, like here it is, a single, just a couple of addresses that I'm going to use to get to this. So it seemed like overkill to do that, where I could do an I/O port, use it within the I/O address space, and free up that 64K, other 64K window out of my 128K video space and use that for something else, maybe back to my original ROM for the system or something else, some other I/O device in the future. But this now will be able to read the data, put it into those flip-flops. These transceivers are going to be used when I go to read out from that I/O port. So it's going to go fetch the appropriate data on the output of these and put it back onto the data bus for the 286 to be able to get to. So that's what the register here is going to do for me. And so far, when I think about the registers, this is what I've laid out so far. So the register will be available at IO address A0. Maybe the highest bit will let me flip between resolutions of 640 by 480 and 800 by 600 on the fly. The bottom 3 bits are going to let me choose the active segment. I only need 3 bits to choose between the 8 different segments within a 512K frame. I'm leaving a spot there in case I want to double that at some point. If I go to a 1 meg frame for some reason, I have an available bit I can use for that to expand that from 8. So 0 through 7, I could go 0 through 15. I have a bit that's going to let me specify for the VGA output which frame should be being used for output, frame 0 or frame 1. Bit 5 here lets me choose from the 286 which frame is it working with. Is it working with 0 or 1 to do writes or reads? So that may or may not be the same as what the VGA is using for the output at the time. So I might be writing to one frame and outputting a different frame. Or maybe I write and output the same frame at the same time. We'll see how that might work out. So I can now set registers accordingly. If I come over to my memory, to get to this VRAM, let's just say I look at frame 0, really I need some logic, and I've got these 157 multiplexers, and it has a pin that lets me choose input A or input B. That's going to go out as my address to the memory. And basically I'm going to have to build logic into this PSOC that says pull the address from the 286 bus or pull it from my VGA logic in the upper right where it's building that address through those counters. Now, one thing on the 286, which is this red line, I'm only doing that on the first 4 of these. And the last one, I'm actually pulling the top part of the addressing from the values in these registers for segment bit 2, 1, and 0. So if this is set, that's actually going to take bit 2. It's going to take the position of, as I come down here, let's make sure I've even got it right. Yeah, I have reg 2 right here, and then I have reg 1 and reg 0, and then the highest bit I'm going to actually run to ground because I am not using the top half of the actual memory that I have used over to the right. But basically bits 19, 18, and 17 and 16, it's going to be a 0, and then whatever those 3 register values are, that's basically allowing me to set my active segment, and now that's going to help me get to the appropriate part of the memory address within this frame that I'm working on. And if I want to work on a different frame, I flip the bit that tells me which frame number I'm on, and then the PSOC will take that into account when it chooses which of these to enable with this basically chip enable flag that it's generating within it. So hopefully that's making sense. Basically what I'm saying is this PSOC is going to have some logic in it that's going to allow me to either take the addressing from the 286 or take the address request from the VGA circuit. And then based on which one is active, it'll actually send those address bits over to the VRAM. And if it is coming from the 286, it's also going to take into account what I've set as my active segment, so that will get me hopefully to the right part of the memory within this. Now on the VGA side, it doesn't have to worry about the segments. It's reading the whole thing as it does its output, at least the whole part of this that I'm making addressable, the 512K of the memory. So that's what these multiplexers are doing here on the left. I do have a little bit of logic up here that just simply says make sure I'm in the space of address 19 is a 1, address 18 0, 17 1, and 16 0. That makes sure that I'm in this A range, A0000 to AFFFF. And I did that separately outside the PSOC because I was running out of pins. So all of that will get me to this video enable signal, and that comes into my PSOC. So I know if I'm receiving a request from the 286 that I should pay attention to on the video card. Essentially that's telling me that, yeah, pay attention. The 286 is trying to write to the memory or read from the memory of this video card. And of course the I/O will come in differently with a lower address. So then my logic will say, well, if it's an I/O read or write, which I'm bringing that information in also, then I'm not going to look at this VGA 286 or this video enable indicator. Instead, I'm going to look at the lower addresses here and make sure that I'm trying to hit address A0 for my I/O. Output is similar here in concept. I've got multiplexers, and then I have to tell it which frame am I using for the output to the VGA. Am I going to use frame 0 or frame 1? And that's going to come from register 5. So it's going to know based on register 5 of my registers that it should be outputting the data from frame 0 or frame 1. If I try to read or write the video memory from my 286, then I have these transceivers down here that, again, I can tell if I'm doing a memory write, then I'm going to send the data in. Otherwise, I'm going to be pulling data out. And then I'm going to actually only enable the output of this chip if I've actually said that the 286 is actively in control of the memory. And then up here, you know, again, which of the frames am I sending out to the video card? So I've got what comes in for addressing, what goes out to the video card, what goes out or in as far as the 286 and data is concerned. And I think that's starting to come together okay the way I'm understanding how this might work. Now what I don't have started yet or entirely figured out is all the logic that's going to have to go into this PSOC for decoding all of this. You know, 80% of it, I think I have a mental plan, so I'm going to have to just kind of get in here and start experimenting with some stuff. You know, the biggest challenge is going to be I have the 286 on one clock, I have this VGA output on a totally different clock, and I've got to make sure that they each get their necessary access to the memory when they need it. They can't both access the memory simultaneously, and so I'm going to have to be creative and see if I can make that work. I think in theory that's doable, but I imagine I'm going to have some stuff to learn as I get into that. So I think that's really where I'm at with this circuit. So, you know, back to, I'm shrinking down to a 64K window on my 286 to access this card, along with this IO register that I can write to. That's going to help me, you know, set these things so that I can allow the proper addresses into the memory to select what's actually going to be output, and then I can have control of, am I going to output stuff to the VGA card, or am I outputting to the 286, or even bringing in fresh data from the 286 to that memory using the addresses that came from the 286. So that is, in theory, how this is going to move forward. So that's what I'm going to be working on next, is actually physically connecting the ICs that you see here, and then getting into all of this PSOC decode logic. And I think I'm out of pins on the PSOC, so I'm going to use every available pin. The ones I'm not using is because they have capacitors on them, and at high speed they do not work well. I think they're more for analog usage or something other than what I'm doing with them. I have all the pins in use on the PSOC. I'm hoping I have everything for inputs and outputs that I'm going to need, but we'll see how that all goes. So that is what I have for now. I will post this current schematic up on my blog in case you want to look at it and point out anything that I'm majorly misthinking, or even if you see something small that I should tweak, do let me know. But I'll come back with an update maybe in a week or two if I can get some of this physically connected. And I'll probably start out with something simple like, can I simply write to the memory and read from the memory from my 286. I won't even worry about connecting any of the VGA part of it yet. And then if I can get that done, then I can move on and try to get the VGA to also be able to access the memory. And I'll build all this decode logic, I guess, as I go, as I'm doing that. And maybe how I'm going to connect that, just as a real quick note, I do have adapters that I can plug into my ISA slots on my 286 board that convert it to a ribbon cable to basically a breadboard adapter, so I can quickly get these same signals onto a breadboard. And I'm going to do all of this on the breadboard, and we'll see how that plays out. I won't be able to run it at full speed, I don't think, so how well of a test I'll be able to put to this, I don't know, but if I can get it to run at low speed, at least that's a partial win. And like I said, I think my biggest challenge, really the hardest thing for this project for me, is the logic that's going to go in this PSOC. Lots to come there. So that's it for now. Thanks everybody for all of the input you've given and the feedback. I appreciate all the great ideas, and I'll keep on working on making this better. And just a quick side note, I have gotten a lot of other ideas that I'm not incorporating yet. I'm kind of making a list of future to-dos on my blog so that I can come back to some of those and maybe try some additional things if I can get this initial base stuff working okay. So more to come. Thanks all.